Hello, I'm Shad. I work for the ONF, and yeah, I know quite a few faces here. So today I'll be talking about OpenOLT, and I think Sergio's talk was a good intro into what I'll be talking about. This is more southbound. Sergio was talking about the core of Voltha, and we'll be looking looking at a layer down from the core. So this is this is a picture that you probably have seen before, and just to give you a context of what we'll be talking today. So we'll be talking about Voltha, and we'll be talking about the southbound of Voltha, which is the adapters. And Sergio talked about the core, which is more on the northbound of Voltha. And this is something that we demoed from ONF in BBWF this October. And in BBWF, we demoed a multi-vendor. It was a multi-vendor demo with OLTs from EdgeCore, Iskratel, CIG, and Atran. And the thing to note is that the EdgeCore, the CIG, and the Iskratel OLTs were all managed by a same adapter that we're going to talk about, and that's the OpenOLT adapter. Atran has had their own adapter. And if you look at the demo, which is in the expo area, you'll again see a very similar demo, similar diagram. And over there as well, you'll have EdgeCore being managed by OpenOLT adapter, and there's also Atran. So Sergio was pretty cutting edge. This is already legacy that we're talking about. So to give you a bit of a context of people who are not working on Voltha day to day, so we have 1.x, and then we have 2.0. 2.0 is coming out this December, and then 2.1 early in the first quarter of this thing. So 2.0 is bringing in the new core, and what's this? Oh, okay. So 2.0 is a new core. So the yellow part is the core, and the iAdapter interface, which Sergio mentioned, is the internal interface right now within Voltha between the core and the adapters. And that is changing from the iAdapter, which was basically a function call interface, to a Kafka level interface. The northbound is again what Sergio talked about, is OpenFlow gRPC REST. And the southbound of Voltha until 1.3, I would say, was vendor specific. So the really common interface of Voltha in 1.3 was the iAdapter interface. And the adapters were, vendors were expected to write their adapters. And you had adapters from Atran, there was one from EdgeCore and Tibet and stuff like that. So there was the vertical implementation of adapters, which with almost no sharing of any infra or code between them. So each adapter implemented its own interface southbound, but there's a lot of repetition of the same thing. And if you observe from Sergio's talk, Sergio didn't talk anything about PON related stuff. There's no PON constructs in the core, and that's by design. And the core is agnostic to technology. So core doesn't really know about that there is a PON network underneath it, to a large extent. And that's by design. So which means that the burden is pushed down to the adapters to manage the PON network. And as you're familiar with in PON, there's the whole list of these functionality. Every adapter had to implement their own, which is ONU discovery, PON resource management, OMCI. The only thing that Chip from Sienna brought in 1.3 timeframe was a common OMCI library that any adapter, that the ONU adapters could reuse. But that was about it. That was the only common infra piece that the adapters could share. So this was what at ONF, when we started working in the lower layers of Voltha, we observed was that there was, as I said, there was a kind of an adapter siloization where every adapter kind of was re-implementing the same functionality. That kind of tended towards a kind of a vendor lock-in, because that particular vendor would only understand their adapter. So if you wanted to use a box from a particular vendor, you really had to go through that vendor for the adapter and understand that the adapter. For white box vendors, initially when we talked to a few white box vendors, it appeared that there was a high barrier of entry for them. They're coming in with a white box OLT, and now they say, how can I integrate my box into Voltha? So we had to tell them, like, there's Voltha, there's ONOS, all the stuff, and now you have to implement an adapter for your box to get it integrated into Voltha. So that looked like an uphill task to them. So so that at ONF we kind of revisited the adapter interface, and this is kind of my observation, or a common observation, that disaggregation kind of works at all levels, but the lower you push it down, it works better, and that's why what we did was initially define a kind of a gRPC interface at the southbound, which is vendor agnostic, and that is kind of abstracting out the Voltha on the southbound, so that an OLT vendor would just have to honor the gRPC interface at the bottom, and plug into that gRPC, and not have to worry too much about writing an adapter or for their particular device. So the adapter interface is still there. What we brought in was an OpenOLT adapter, which can be reused, or if a vendor wants to add value add, or is doing things differently, can subclass that. So this is exactly how the CIG and the Iskratel and even the Tel Labs OLT adapters are implemented as subclasses. For the base class, the base OpenOLT adapter, we tested with the H-core OLT, and that and the subclasses, the vendors have their own subclasses for that. Around the same time, Radisys took the lead, and along with Tel Labs, they pulled out they implemented the common infra of resource profiles and tech profiles. So now we have a good common infra in the adapters that can be reused. And also around the same time came the Broadcom OMCI adapter based on the OpenOMCI, which again is being subclassed, is being customized by the vendors. So this is things that happened like post 1.3 timeframe, and this is how it is right now. This is and the gRPC interface is kept pretty simple, and it's growing as more and more functionality is being added into the OpenOLT adapter, or features are being added. And this is we are looking at it from the device side. On the device side, what we have is C++ gRPC common layer that, that implements the gRPC interface. Right now, it links with a shim for the Broadcom SDK. This is the BAL SDK. And we have written a shim layer that translates the gRPC to the Broadcom shim, to the Broadcom SDK. And you can see over here that we are really dumbing down the device. We're trying to take away as much intelligence as much as possible out of the device over here. So the gRPC interface is kept pretty low level. The gRPC interface is a streaming interface, which is that the device, you see on the right-hand side, the device is constantly sending indications up to the adapter. Those are unsolicited indications. And then you have command requests, command responses, which are originated from the adapter. This interface over here is kind of informal right now, but it is easily, it's easy enough to be able to take this out and use it with a different backend. Let's say you have an FPGA-based OLT. You could still reuse this common part over here with your own backend SDK or FPGA backend. Looking a bit into the OLT adapter itself, it's the OpenOLT adapter is the one that talks to the iAdapter interface. There's one per system. That's just, and then you have the OpenOLT device, which is one per OLT instance. And the OpenOLT device class implements the core functionality, which is the ONU management and interface management. Basically the ONU management and the state machine of the OLT itself. There are other supporting classes, and we have designed it this way so that if a particular vendor has a different has to implement a different functionality for a particular in a particular area, they can easily subclass these classes out or implement their own, substitute their own. Okay. NTT, Kieta from NTT worked on the BBSIM, which is basically implements the OpenOLT API. So, and this is what we used in the BBWF demo, and you can see it out here in the expo area as well. So, an instance of the BBSIM simulates a single OLT with multiple ONUs. You can configure how many ONUs to start with and how many interfaces to start with. And it also has some minimal simulation of RGs, which implement EAPOL and DH client. So again, you see over here that we have a nice way of exercising the OpenOLT API, and I think right now there's no alarms and PM metrics over here, but things fault management can be implemented into this. So this is OpenOLT is right now was started by ONF with contributions from AT&T Foundry. There's Craig from Tell Labs. He's now very actively contributing to it. I think the main work going forward in 2019 is the containerization connected to the work that Sergio mentioned. Integration with SEBA is what at ONF we were working on for the past couple of months. Also, robustness, scale, and BBSIM is things that at ONF we were focusing on in the past couple of months. And resource and technology profiles coming from Radisys and also with help from Tell Labs is already integrated with OpenOLT, and I think there's still some work over there. And I should mention also that Labs has contributed work to support multi-technologies on single OLT. I think I've not been following too much on that, but the ability to support GPON and XGS on the same box per port configuration. So that's something new that's come in. I forget what the software image download. There's talk about support for hierarchical QoS and to build that into OpenOLT and multicast as well. There's asks for it from some service providers. So these are some of the things that I think in the very near future, in the first quarter, in the first half of 2019, that we'll be focusing on. So that's about it. And if there are any questions, yeah. Yeah.
Is that part of the model?
No. So this is the OLT adapter is controlling just the OLT, but also acts as a proxy for the OMCI messaging. There's a similar adapter. The model is adapters for OLTs and adapters for ONUs as well. So if you're using, for example, we use mostly Broadcom-based ONUs. So there's a OpenOMCI-based Broadcom ONU adapter. So there are two adapters. One is OLT and another an ONU adapter.
Sorry, my question's not clear. So the ONU, there were two types. One is the layer 2.
Yeah.
Meaning there is a separate device, RG.
Okay. Yeah.
There's another version of ONU, including RG, including Wi-Fi, everything else.
Right. Yeah.
So does your model scale up for the one with the router function?
Yeah, so we right now our testing is only it's not with the integrated RG ONU. We at least in the labs at ONF we don't have any of those. So we have just ONUs and we plug in dummy RGs behind that, Linux servers behind that, Linux boxes. Yeah, but the model supports it. Yeah.
I think AT&T added VID support. And then
Yeah.
TL69 configuration is via band management channels into the RG part.
Right.
It may depend operator to operator.
Yeah.
Yes, AT&T has in-band management over 69, like Sean was saying. So we're not going to be managing the RG side of the integrated device through SEBA ONOS. So we would just be managing the layer 2 side. Not to say that another operator might want to do something different, which should be supported, but is a future application.
Right.
I will have to say that depends on the use case, right? So today, like Mike was saying, but right now we have not, I think on the service provider side, we have not seen any use case of the integrated RG function on the ONU yet on the workflow. So once that got introduced, I think it will be explored more. But the OpenOMCI stack already supports all those stuff. But there's no use case right now being proven to has not been brought on the table yet. Okay, so I think it's a priority, and then how on everybody's POC activity, what they're going to do. I think what he was also saying, because BBSIM, you have the RG over there.
Yeah.
So the BBSIM, whether you are going to have that different model of the ONU in the BBSIM or not.
Yeah, that is a very test kind of a thing. The RG over there, I just meant that we have like a capability to inject EAPOL and act as a DH client over there. That's what I was trying to represent over there in the BBSIM case. The ability to just start EAPOL and DH client. There's nothing other than that in BBSIM right now. Yeah.
Just want to clarify something. I thought you said, is the OpenOLT adapter vendor agnostic?
We're trying to keep it that way. That's why it is able to be. We can use it with at least three boxes from 3 vendors right now. So we're trying to keep the API, the protobuf API agnostic. So it's a community-driven thing. You bring in, let's say you bring in your box and it needs a certain change in that API. You propose that, and if everybody's okay with it, it gets included. And yeah, Obviously, there'll be discussion as to is it generic enough for everyone else and things like that. Yeah.
I think there's multiple models, right? I mean, there's the model where you can use the OpenOLT adapter as it is.
Yes.
There's the model where you can subclass and provide your own specific implementation, and then there's a model where you can write your own adapter. I think
That's right. Yeah.
We have all of those models today.
Correct.
But
Yeah.
we would like to have the open one be as ubiquitous as it can be.
Right. Yeah. You can subclass it, the functionality, but there's also the protobuf, that the messaging between that, and it'll be nice to keep that common. The interface common, and then your implementation behind it. If it you can be different. Yeah. That's right.
Core into it, if you will.
Yeah.
Or
Yeah.
you can use it as is long as you code your client side.
Yes. Yes.
In 1.x right now, we actually have multiple vendors. The one open for everybody to review. I think CIG has their own adapter, and then they also have adapter integrated with the OpenOLT adapter, and Adtran has their OLT and ONT adapter also. Those are all in the repo already. So.
Yeah. So you can honor the iAdapter interface, or you can build your own adapter, talking to the iAdapter interface, or use subclass of OpenOLT adapter, or reuse the OpenOLT adapter itself.
So the three models are you can continue with your current adapter compliant with Voltha core, use OpenOLT as a framework, or use OpenOLT in its entirety.
That's right. Yeah.
Serkan, you had a question?
Yeah, I was going to ask this to Sergio, but Sham didn't let me.
Thank you.
So what was I'm wondering, what was the main reason of containerization of adapters? I believe there are one-to-one relation between repo and adapters.
I think the initial idea is, each individual adapter, especially for the different vendors adapter.
Now we have the OpenOLT adapter.
Now we have OpenOLT adapter, then, but still we don't want to lose that loose couple kind of framework, modular framework, right?
So I think I need to make a correction. There is not a one-to-one association between a core and an adapter, right? The binding is to the device, and that can be in any of the cores. In any of the cores in their redundant model, right? Depending on affinity and how that's established. The other reason was all the adapter code was in the core. It didn't make any sense. We're trying to build disaggregated systems, and there was a bunch of aggregated stuff that didn't belong in that one place, so we split them.
To add a new adapter, you had to split the core.
Yeah, you have to create a new core.
It's modularity.
Yeah.
It's to be able to let the core be the core and
Yeah.
be able to add a subclass adapter from any vendor who came on and needed to add a new adapter.
So you
It's
can
not
add it
about
well.
the scalability of
It is a scalability, because you think of it clustering. You can have a cluster of adapter containers. Okay, so and then you could have, and then there's a cluster of the core containers, and the independent. Yeah.
You can put in a new core for a new adapter for a new device without upgrading your core. The old model was you needed to upgrade all your core containers to have the code for the device.
Wait, one more minute. I just want to make a little bit correction also, is that I think the technology profile and research manager, I think the Deutsche, Turk Telekom has also had
Oh, yeah.
a lot of contribution.
Yeah.
And then,
Yeah.
and actually Deutsche Telekom has a lot of behind the scene work also, so it's definitely an effort among an entity BBSIM. So everybody has working together within this framework, try to get this established. Again, so the 2.0 release is middle of the January, only include the containerization of the OpenOLT and ONU adapters is not part of the 2.0 release. We have additional sprint to get that delivered. So now we have the next topic.
You had a question? Yeah.
Yeah, I was just curious if this is more like a roadmap or a wish list.
No. This is just something I put up yesterday. I mean,
Are you committed to actually delivering all of those, or is it something you'd like to deliver?
No, this is something. This is just something on the top. I just put up over here, and this is nothing official.
No, the community
Yeah.
will ask you to deliver these.
It's not a roadmap.
Yeah,
It's not a roadmap, but it's the community requirement too. So I think on the service provider side.
yeah. It's a exactly. Yeah.
Okay, so thanks, Shad, and then
Thank
we
you.
have Chip coming up for the OpenOLT CI work.